In section 5.1, we're going to start talking about zero and negative exponents. Something I'm going to tell you though is while the book calls them exponents, and I'll still call them exponents as well, I'll be using the word power a lot more as we go through this chapter. Now, this entire chapter is actually going to be over functions, which you've done, but all you've done is linear functions. You're going to learn two new types of functions, which are exponential functions and radical functions. But first, we have to go over a few rules on exponents. Look at the solve it problem, or the blank space at the top of the page. I'm just going to have you write down a few rules or a few problems. I want you to write down first 5 to the 0 power. I then want you to write down negative 5 to the 0 power. In parentheses, I want you to write negative 5 to the 0 power. And then I want you to put negative, and then in parentheses, 5 to the 0 power. Now the rule you're going to note is that anything to the power of 0 is 1. That's actually written in the take notes section in the middle of this page, which we're on page 283. 5 to the 0 power is just going to give you 1. Now here's what I want to ask you. What do you think this is going to be? Negative 5 to the power of 0. Do you think it's going to be 1? Let's come back to it. The next one is negative 5 to the power of 0. That will be 1. And the last one, the negative's on the outside, so 5 to the 0 power is 1, and the negative just comes over. So back to this one. This answer is negative 1. Here's why. 5 is being taken to the 0 power. That's it. Only the 5. The negative is still out front. It would actually be like if you took negative 1 times 5 to the 0 power. That would give you negative 1 times 1, which gives you the negative 1. That's kind of another way of rewriting that problem. So look at the middle of the page. In the middle of the page, you have a property section. 0 as an exponent. We just talked about that. For every non-zero number, it can't be 0. So any number other than 0, if you take it to the power of 0, you will always get 1. And they give you 3 examples. However, the next part is a little trickier. Let me explain this to you. The rule states that if you have a non-zero number, which we're going to call it A, that's your base, and you have a negative exponent, which we're going to call it an integer n, we're actually going to get 1 over a to the n. So let me put that as an example. 7 to the negative 3 power. 7 to the negative 3 power is going to give you 1 over 7 to the third. And then you'd actually simplify it one more step and put 1 over 343. That's 7 times 7 times 7. Then, let's say we have 3 to the negative 2 power. That's going to give you 1 over 3 squared, which gives you 1/9. Here's what's happening. You are taking the value of the base, which is to a negative power, and you're flipping it. So it'd be like writing 7 to the negative 3 over 1, and then it goes to the bottom. 3 to the negative 2 over 1, the 3 to the negative 2 goes to the bottom. And when it does, it becomes positive. So let's do another example. Negative 5 to the negative 2 power. That's going to flip, going to give you negative 5 squared, which would then give you 1/25. Notice that the negative power doesn't make anything negative. A negative power does nothing with making something negative. So it's not like multiplying by a negative. You are only flipping it and then simplifying it by that power. Now look at the bottom of the page in the gray region. It's important to understand what happens when we use 0 as a base. So here's what it says. Why can't you use 0 as a base with 0 exponents? The first property implies the following pattern. So if you look, 3 to the 0 is 1. 2 to the 0 is 1. 1 to the 0 is 1. And then it says 0 to the 0 is 1. However, consider the following pattern. 0 to the third is 0. 0 to the second is 0. 0 to the first is 0. But the 0 to the 0 is not 0. I mean, it is 0. But it's actually, if we followed our rule, it would be 1. So then it says, it is not possible for a 0 to the power of 0 to equal both 1 and 0. Therefore, 0 to the 0 power is undefined. I suggest you circle that. If you take a base of 0 to a 0 power, it's undefined. Why can't you use 0 as a base with a negative exponent? Using 0 as a base with a negative exponent will result in division by 0, which is undefined. Make note of that. You cannot have a 0 to a negative power because you are going to get something divided by 0. So it would look like this. Let me write it down. 0 to the negative 2 would become 1 over 0 to the second. Well, 0 to any power is just 0. But 1 divided by 0 is undefined. You cannot divide a number by 0. Therefore, this does not work. That is why you cannot have 0 as a base. Problem 1. You're just going to be simplifying expressions using the two rules on the front. So we're going to do all 5 got it problems. A, 4 to the negative third power. We're going to flip it. It's going to become 1 over 4 to the third power. It becomes a positive power. And then we take 4 times 4 times 4. 4 times 4 is 16. And 16 times 4 is 64. So we get 1/64. B, anything to the power of 0 is 1. C, 3 to the negative 2 power. We're going to flip it. It's going to become positive. 1 over 3 squared, which becomes 1/9. D, 6 to the negative 1 power. It's going to become 1 over 6 to the 1 power, which is just going to give us 1/6. And E, that's going to become 1 over negative 4. You must keep that in parentheses. Negative 4 to the second power. Remember, it becomes positive. And negative 4 times negative 4 is positive 16. So my answer is 1/16. That's all you do, following the two rules. All right. Problem 2 is the same thing as problem 1, except now you have exponential expressions. Remember, an algebraic expression is in simplest form when powers with a variable base are written with only positive exponents. So if you notice where I read that from, I read that right at the very top in the gray region. Put a star next to that, or put a highlighter, do something. You need to understand, if you are going to simplify an expression, for example, let me just write this down up here, 4x plus 2x. You know that that is not simplified because they're like terms. So you would actually write 6x. It's the same thing with all of these. You cannot have an expression in simplest form that has a power of 0 or a negative exponent. You must have only positive exponents. If you do not have positive exponents, you must make them positive. So now we're going to use letters. So go to A. Part A, x to the negative 9th. We're going to flip it. Now remember, really, this is on the top. It's going to go to the bottom, and it's going to become positive. So 1 over x to the 9th is your answer. B is a little different. The end of the negative third is on the bottom. Because it's on the bottom, it's going to move to the top. And when it moves to the top, it becomes positive. So you would actually get end of the third over 1. You do not need to write the 1. C. 4c to the negative third times b. Now, once again, this is like it's over 1. The c is the only thing to the negative third power. So this, what I'm boxing on red, this is 4 times c to the negative third times b. The c to the negative third is what has to move to the bottom. The 4 and the b are going to stay put. So they're going to stay on top. The c to the negative 3 goes to the bottom and becomes positive. And there's your answer. D, 2 over a to the negative third. A to the negative third is going to go to the top. When it goes to the top, it's going to become positive. 2a to the third is your answer. The last one, n to the negative fifth. The n to the negative fifth that's a negative, so that's going to move to the bottom. The m squared will not move because it's already positive. If you move it to the bottom, there's a 1 left on top, and on the bottom you'd have m squared, and the n, it becomes positive 5, so it becomes m squared n to the fifth. So your answer is 1 divided by m squared times n to the fifth. I want you to do one more, just because I want to make sure you really understand this. Let's do F. I want you to do 3x to the negative 2, y to the fifth, over 4, let's do w to the negative 3, z to the 0. We're going to do a hard one. In this problem, the x to the negative 2 has to go to the bottom because that's negative. The w to the negative 3 would have to go to the top. And the z's to the 0, anything to the power of 0 is 1. So my final answer would be 3. The w moves to the top and becomes positive, w to the third. Y to the fifth doesn't move because it's already positive. In the denominator, the 4 is already there. The x to the negative 2 goes to the bottom and becomes x squared. And the z squared just becomes 1, but we don't need to write that since it's times 1 anyway. So that is your answer. There is a lot of work in there, but you just got to know those rules and just practice it. Part 3 is evaluating an exponential expression. What that means is now they're going to give you a value of the variables. So in A through D, n is equal to negative 2 and w is equal to 5. Now the gray box at the top of page 286 says that when you evaluate an expression, you can actually simplify the expression before you substitute in the values of x or y or any other variables. So for example, some of you may think, well, I'm just going to take the negative 2 and plug it in right now. And I'm going to take the 5 and plug it in right now. You absolutely can do that. But I'm going to simplify first, and then I'm going to substitute. So here we go. I'm going to put it over 1. This moves to the bottom. And w to the 0 power, that's just 1. The n to the negative 4 goes to the bottom, and it becomes 1 over n to the 4th. Now I'm going to plug in. It is important, and if you don't get the hang of this, I will count it wrong because this is not mathematically correct if you write it like this. N is negative 2. If you write it like this, negative 2 to the 4th power, that is not correct because you are only telling me that you're taking 2 to the 4th power. You are taking the value of negative 2 to the 4th power, so that has to be in parentheses. So, 1 over negative 2 to the 4th power. So negative 2 times negative 2 times negative 2 times negative 2. Here's all I do. I just take 2 to the 4th power. Well, 2 to the 4th power is 16. And a negative to an even power is just positive. So my answer is going to be 1/16. B. The n to the negative 1 goes to the bottom. So that's going to give me 1 over n to the first, which is just n, w squared. Now I plug in my values. N is negative 2. W is 5, so it's going to be 5 squared. Got to follow order of operations. 1 over negative 2 times 5 squared, which is 25. That's going to give me the fraction negative 1/50. And that's my answer. C. N to the 0 divided by w to the 6th. N to the 0 just becomes 1, and then divided by w to the 6th. 1 over 5 to the 6th. And 5 to the 6th, I actually do not know, so let me pull up my calculator real fast. So 5 times 5 times 5 times 5 times 5 times 5, which is 5 to the 6th power, gives you 1 over 15,625. Last one. 1 divided by nw to the negative 1. The w to the negative 1 is going to go on top. So w over n. W is 5 divided by negative 2. My answer is negative 2.5, or you could just leave it as negative 5/2. We are now at the top of page 287 with problem 4. We're now actually going to use an exponential expression within a word problem. So it says a population of insects triples every week. The number of insects is modeled by the expression 5,400 times 3 to the w power, where w is the number of weeks after the population was measured. Evaluate the expression for w as w is equal to negative 2, w equals 0, and w equals 1. What does each value of the expression represent in the situation? So we're going to plug in 5,400 or 5,400 times 3 to the negative 2, 5,400 times 3 to the 0, and 5,400 times 3 to the 1. Well, 5,400 times 3 to the negative 2 is actually going to become 5,400 divided by 3 squared, because remember this right here becomes 1 over 3 squared. So 5,400 times 1 is just 5,400. So 5,400 divided by 9, 5,400 divided by 9 is going to be what? It's going to be 600. Next one, 5,400 times 3 to the 0 power. 3 to the 0 power is just 1, so that's just going to give us 5,400. Then 5,400 times 3, well, 3 to the first power is just 3. So 5,400 times 3 is going to give us 16,200. So in the word problem, here's what this means, because these numbers mean nothing to you until you put them into an actual word problem, or until you put labels on them, meaning. So what did W represent? It said W is weeks, and this is the population. So we're talking about insects. So this means, like 2 weeks ago, there would have been 600 insects. In 1 week from now, there's going to be 5,400 insects. Zero is actually going to be right now. So currently right now there are 5,400. 2 weeks ago there was 600. And in 1 week, the population of insects will be 16,200.